everyone, this is Vishwesh and we are in the series of videos on aptitude skills. So in this video we are going to see the topic permutations and combinations, and this topic is very important. We can say that it is frequently asked topic. So let's go through this video. So in this video we are going to see the logic of these two, permutations and combinations, the strategies and how to solve the questions that first we will see, and then few practice questions from low difficulty, medium difficulty and high difficulty. So let's go with it. So to understand the concept, we will first go through this question. In how many ways can we select 3 letters from 5 letters, and how many different words can be formed out of the selected 3 letters? Okay, so we can assume any 5 letters like A, B, C, D, E. Let's assume that these are the 5 letters. Now out of these 5 we can select any 3. So we have to select 3 letters out of these 5. So it may be this A, B, C, or it may be B, C, D, or it may be C, A, E. So randomly we can select any 3 letters. Now how many ways are there? How many ways are there that out of 5 we can select any 3 letter? How many different combinations are there? So for this the concept combination is used, and it is having the formula NCR. NCR gives n factorial upon n minus r factorial into r factorial. Okay, so in this case 5 letters are there and we have to select 3. So let's apply the formula. So formula will be 5C3. So from 5 letters we have to select 3, and this gives 5 factorial upon 5 minus 3 factorial, which is 2 factorial multiplied by 3 factorial. Now 5 factorial we can represent as 5 into 4 into 3 factorial divided by 2 factorial will be 2 into 1 multiplied by 3 factorial as it is. Now this 3 factorial we can cancel. 2 1s are 2, 2 2s are 4, and this gives answer as 10. So 10 different ways are there in which we can select 3 letters out of 5. Got it? So this is first part, combination. So in combination it is all about selection. Combination is all about selection. Okay. Now let's talk about permutations. In case of permutations, earlier we have selected 3 letters out of 5 when we were discussing about combination. So let's assume that these 3 letters are A, D, E. These are the 3 letters that we have selected. Now in case of permutations, for these 3 letters the arrangement may differ. Now here we are talking about the arrangement. Okay, it may be arrangement, or it may be sequence, or it may be the order in which we can select and we can position these letters. So ADE may be the one output, AED may be the second output, or D we can have first, AE will be later on, again D first, EA, or it may be E first, A and D later on, or E first, D and A. So these are 1, 2, 3, 4, 5 and 6. 6 different outputs for the same 3 letters. So in case of permutations, the arrangement, the sequence, the order will be considered. It will be considered. So in case of permutations, if we want to check how many outputs we have, we will be using the formula NPR. NPR. In case of combination it was NCR. In case of permutations it is NPR, and this is given by n factorial upon n minus r factorial, bracket factorial. Correct? So let's apply this formula over here in case of this 3 letters, selection of 3 letters and different combinations. So it will be 3p3, and this will be given by 3 factorial upon 3 minus 3 bracket factorial. So this is equals to 3 factorial upon 3 minus 3 is 0 factorial. 0 factorial is 1. 3 factorial is 3 into 2 into 1, and 0 factorial is 1. So this gives 6, and here we have 6 combinations, 1, 2, 3, 4, 5, 6. So this is how in case of permutations the arrangement, sequence and order will be considered. So this is how these two things are different. If it is only about selection, then combination we can use. If it is the order or the sequence is also mattering, then we have to go for permutations. Now let's try a few examples. Now here first we have low difficulty example. The question is, in a party there were total 20 people. Each person shook his hands with other person. Okay, how many handshakes would have been taken place? Now this is the question. So 20 persons are there. Now if we select any one person out of 20, let's say first person. Now this first person will be shaking hands with other 19 persons. Then there would be second person, he will be sharing the hands with again 19, but he already have shaken the hand with first. So here 19 will be not the number, 18 will be the number. Remaining 18 persons he will be shaking hand. So first person is shaking hand with second or second is with first. It is nothing but the same thing. Correct? So here order will not matter. Here sequence will not matter, and that's why it is the problem of combination. So in this case 20 persons are there, and out of 20 each time 2 persons will be shaking the hands. So 20C2 is the formula, and if we solve it we will get 20 factorial upon 20 minus 2, 18 factorial multiplied by 2 factorial. So this gives 20 into 19 into 18 factorial divided by 18 factorial as it is, so that we can cancel it, and 2 factorial is 2 into 1. 18 factorial we can cancel. 2 ones are 2, 2 tens are 20, and 19 into 10 will give 190, and here 190 answer is correct. I hope you have understood this. Let's go to the next. Now this next question is about medium difficulty level, and the question is, from a group of 7 men and 6 women, 5 persons are to be selected to form a committee. So out of this 7 and 6, 7 plus 6 is how much? It is 13. So out of 13 we have to select 5 persons, and the condition is out of 5 at least there has to be 3 men. Okay, at least there has to be 3 men. Now in how many ways we can do this? So total 7 men are there and 6 women are there. Now out of 7 men we have to, out of 7 men and 6 women we have to form the committee of 5 persons. But condition is at least there has to be 3 men. Now at least there has to be 3 men means 3 is allowed, 4 is also allowed, and 5 is also allowed. So in one of the possibilities 3 men we can have, and remaining 2 we can have women. So this can be one of the possibility, or we can have 4 men and 1 woman, or we can have 5 men and 0 women. Correct? So these 3 possibilities we can have, 1, 2 and 3. Now here how will be the formula? Now it is again all about combination, because this is all about selection. We just have to select. We are not worried about its order or sequence. So it is all about combination. We have to use the formula of combination. Formula of combination is NCR. So here we have to select 3 out of 7. Correct? So the formula will be 7C3. The formula will be 7C3. And then there is AND in between. AND says multiplication. Then we have to select 2 women. So it will be 6C2. 2 women out of 6. 6C2. Then next there is OR. So OR says addition. Then 4 men are there. So 7C4 multiplied by 1 is there. So 6C1. Again plus 5 is there, so 7C5 multiplied by 0 is there, so 6C0. So this calculation will give the final answer. This calculation will give the final answer. So how to calculate 7C3? I hope you know the formula. Here I can write it down. NCR is n factorial upon n minus r factorial into r factorial. So using this formula you can calculate this plus this plus this. So I hope you will be able to do this, and once you calculate this you can post the answer in comments. So let's go to the next question. Next question is again of medium difficulty level, and the question is, in how many different ways can the letters of the word leading be arranged in such a way that the vowels always come together? Okay, now this question is medium difficulty level. You can pause the video and try that how you can solve it. Try solving this. If not possible, obviously you can go through this solution. So we have to find out the different arrangements. Now this is all about arrangements, and arrangements is nothing but permutations. So here we have to use the formula NPR, which is n factorial upon n minus r factorial. Correct? So let's use that formula here for the word leading. Now in case of leading, we have the letters like L, E, A, D, I, N, G. Okay, so we have 1, 2, 3, 4, 5, 6, 7. Total 7 letters are there. But out of 7, there are vowels like E, A, I. These 3 vowels are there. So out of 7, 3 vowels are there. And the condition is vowels has to be together always. For example, we can have one of the combination like this. We can take vowels together E, A, I, and remaining letters after that. So maybe this one is one the output, we can say one of the option, or it can be like this: D is first, then I, A, E, and then remaining consonants. It may be this, or it may be like this: L, D, L, N is there, A, E, I, and G is later on. It may be like this as well. So what condition is, these vowels has to be together always. All the vowels has to be together always. To make this possible, what the trick is, we can consider this as one entity, the single entity. So how many letters we will have then? This one letter as single entity, then this second, third, fourth, fifth. So total 5 letters we have that we will consider. Total 5 letters we have if we consider vowels always together. And how can we arrange 5 letters? The arrangement of 5 letters. So we can use NPR formula. So from that we can calculate NPR 5P5, because we have to consider arrangement of 5 letters in 5 different ways. So 5P5, and that gives 5 factorial upon 0 factorial, which is 5 factorial. Okay, so this is part of the answer. And also we have vowels together always. In this 5 factorial ways we have vowels always together, which are 1, 2, 3 vowels. So these 3 vowels also may interchange the position. For example, in this letter it may be E, A, I, or it may be A, I, E, or it may be I, E, A, or it may be few more. So to consider these, we can have one more NPR formula in which 3P3 we will consider. 3 vowels and their arrangement. So this gives 3 factorial upon 0 factorial, which is 3 factorial. And what to do with this 5 factorial and 3 factorial? We have to, the final answer will be 5 factorial multiplied by 3 factorial, and this will give the final answer. So for this question, the final answer is 5 factorial multiplied by 3 factorial. Correct? Let's go to the next. Now this is high difficulty level question, and the logic is same. The part of the question is same, just like previous. The question is, in how many different ways can the letters of the word corporation be arranged so that the vowels always come together? Okay, so here how many letters we do have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total 11 letters are there. and out of 11 how many vowels do we have? 1, 2, 3, 4, 5. Out of 11, 5 vowels we have. Okay. Now again vowels has to be together. This is the condition. Vowels has to be together. So 5 letters has to be together. We can consider these 5 letters as one entity or one letter. And by doing that, how many letters we can have? So 11 minus 5 is 6 and this 1. So total 7 letters are there. Okay. 6 letters and this one entity. Total 7 are there. These 7 letters can be arranged in 7 factorial ways. We already have solved this. We have seen this logic. So this 7 factorial will be the part of answer. And since 5 vowels are there, these also can interchange the position with themselves. So 5 factorial will be multiplication. Correct? So this should be the final answer. But here in this example, we have O and again O 3 times. It is repeating. Similarly, we have R and R 2 times. It is repeating. So to compensate this, we have to divide this 7 factorial by 2 factorial because R is coming 2 times. And since O is also coming 3 times, here we can see 3 times, we need to divide this again by 3 factorial. So whichever letter in the given word, whichever letter is repeating, the times it is repeating, that number we have to just divide the factorial. So here 2 factorial and 3 factorial we have to divide. Now this calculation will give the final answer. 7 factorial into 5 factorial divided by 2 factorial and again divided by 3 factorial. The final answer will be given by this calculation. I hope you understood this. Now let's go to the next question. Now this will be the last question again of high difficulty level, and what the question is: there is a meeting of 20 delegates that is to be held in a hotel. In how many ways these delegates can be seated along a round table? It is along a round table if 3 particular delegates always sit together. So it is just like vowels and consonants, all vowels together. Here we have 3 delegates together. Okay. Now when we are considering 20 delegates and these delegates are sitting around a round table, if we have, let's say, 3 delegates, A, then B and C here. Okay, let's consider an example of 3 delegates. In this case, how many ways are there? Now for this we have to select either clockwise or anti-clockwise. Let's go with clockwise. So clockwise, and if we start always with A, then one of the ways is A, B, C, and again A. Since it is round table, A, B, C, A. Correct? This can be one of the way. Second way can be, we can have this A over here. Instead of this, we will have it over here. And now the sequence is, second number of sequences, A, C, B. A, C, B, and again A. So if 3 delegates are there, we can have these 2 arrangements. Now there will be no third arrangement. If we keep this B between A and C, it will be again A, B, C, A, which is first option. If we keep this C in between B and A, it will be again A, B, C, going clockwise, A, B, and then C. So if you think and if you brainstorm here, you will come to know that only 2 possibilities are there. That either it will be ABC, 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 or it will be ACB, 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 ACB. Since it is round table, we can move along it many times. So this is how, if 3 delegates are there, we have only 2 possibilities. If 5 delegates are there, we have only 4 possibilities, and so on. Okay. So this is how we can have this in generalize. We can have this: if 3 delegates are there, 2 factorial will be the possibilities. 5 delegates are there, 4 factorial will be the possibilities. This we can generalize. Now in our case we have 20. Now let me erase this first so that we will have space to solve the question. Now in this case of our example, 20 delegates are there. So 20 delegates and sitting in a round table, these can be accommodated in 19 factorial ways. Got it? And the one more condition is there, that three particular delegates always sit together. Now in case of round table, again if we consider it like this, A is there, B is there, C is there, D, E and F. Let's say 6 delegates are there, and if we see, or if we put the condition that these three, A, B, C, these three has to be together always, then these 3 delegates can be seated in again 3 factorial ways. They can themselves, they can change their position. So this way 19 factorial into 3 factorial will be the final answer for this question. Got it? So in case of the calculation, you can calculate it 19 factorial multiplied by 3 factorial, and the final answer will be the correct answer. Okay, so this is how the questions on permutations and combinations can have different logics. The more you practice, the more confident you will become in this topic. So my request, sincere request will be, have as much as more practice. Okay, so let's end this video here. Thank you.